solve the following equations. So these questions are from 2014. I think this should be 2013, but I may remove it because this one together with this from another category. So I'll remove these two. We can solve them separately. So to solve these problems, we have this method known as factorization or completing the square. So you can use one of these two methods to solve. You can also use the formula, but these are straightforward, so you don't have to go through all that. Before we get started, just look at this. We have 0 times 100 is equal to 0. We have 5,000 times 0 is equal to 0. We have 0 multiplied by 0 is equal to 0. So do you think the product would still be 0 if this was not a 0? If this was not a 0, if these two are not zeros? And as you may have guessed, the answer is no. It's not possible to get a 0 when you are multiplying two non-zero numbers. So every time you are multiplying two numbers, A and B, these are just some general numbers, and your product is 0, it means either A is equal to 0 or B is equal to 0, or even both. Like in the third case, A and B are both zeros. These three here are the only possibility for you to get a 0. So throughout this lesson, we shall take advantage of this fact to solve for the unknown. So let's start with part B. Part A has a different concept. This one is known as the completing the square method, unless you want to expand it and use different methods. So I want to apply what I've just talked about in the introduction. So we have 4y squared minus 8y is equal to 0. So now you can factor the y out so that you have y. As you can see, y is common. If you want, you can even factor out 4y. 4y into 4y squared is y. Then 4y into 8y is just a 1, a 2 rather. Then this is equal to 0. So now, as you can see, we have 4y being multiplied by y minus 2, and the product is 0. So that means either this is a 0 or this is a 0, or both numbers are zeros. Otherwise, the product will not be a 0. So 4y is equal to 0, or y minus 2 is equal to 0. And then from here, we can easily solve for y by dividing both sides by 4. So y will be 4 into 0 is 0. Then this side, you can just take the 2 to the other side, so that y is equal to 2. So let's skip question A again and move on to part D. I removed part C because this one was covered in indices. So it's not even a quadratic equation because the power is 3. So let's look at part D. On part D, we have 4x squared is equal to 9x. So to solve for x here, you can just repeat the same procedure here. Just bring the 9x this side, and you have a 0 like that. And then you can factor out the x like this, and then this one will be 4x minus 9 is equal to 0. And then once you have this, you can always conclude that when two numbers are being multiplied, this one is treated as a single number. So when two numbers are being multiplied and then the product is 0, it means either this is a 0 or this is a 0 or both numbers are 0. So we can say either x is equal to 0 or 4x minus 9 is equal to 0. So now this one has been solved. By the way, these equations will almost always have two different values. We have special cases where the two x values are the same, but that's not the case here. So to solve for x here, you can just take the 9 to the other side. So you have 4x is equal to 9. And then now let's divide both sides by 4 like this. So x will be 9 over 4. And you're done. So x is either 0 or x is 9 over 4. You can even substitute these values there and you will be able to see that they are both correct. And then this one has already been simplified. So let's try it. We have 2x minus 5 and then x plus 3. This is equal to 0. So now this is one number, this is another. We can conclude that when two numbers a and b are being multiplied, as we saw in the introduction, then either a or b or both are zeros, or maybe is a 0. So since we have 2x minus 5 being multiplied by x plus 3 and then you're getting a 0, it means at least one of these two is a 0. Which of these two is a 0? We really don't know that and we don't really care. So you can just say 2x minus 5 is equal to 0 or x plus 3 is equal to 0. So the moment you say "or," then that's enough for you to solve for x. You don't really have to know which one will be a 0. It's possible that this can be a 0, this can be a 0, or they can both be zeros. So now let's take this one to the other side. So you have 5, then divide both sides by 2. So your x will be 5 over 2 or 2, 1 and 1 over 2 like this. Or using this, x will be negative 3. So when you substitute this in there, you realize that this part will be a 0. And then when you multiply it by that, you get a 0. You use this one, you substitute it in there, you have a 5 minus 5, you have a 0. 0 multiplied by this, you get a 0. So that means the two numbers are both correct. And then part F. On part F, we have 4. I think we solved this. Yeah, we had the similar question there. So this is actually the same question. I repeated it more than once. And then we have x squared minus 2x is equal to 0. As you may have guessed, you just factor out the x, and then here you have x, there you have a 2 after you factor out the x. Then since we are multiplying these two, either x is equal to 0 or this part here, x minus 2 is equal to 0. So when you take the 2 to the other side, the negative 2 to the other side, you have a positive 2. So x is 0 or x is equal to 2. And then I think we can go back to question 1 because this is just like this question. So you can easily solve this. And then this one is somehow related to the first one. And then part K, is more like this one and that. And then, okay, so let's start with this one here, part J. So on part J, we have 2x squared is equal to 8. So to solve this, you can just divide both sides by 2. And then you have x squared is equal to 4. So with this one, if you want, you can bring the 4 to the other side and factorize it using a method known as difference of two squares. But the easiest method here is to introduce the square root on both sides, since we have a square there. And then once you introduce your square root this side, you can say plus or minus, which means your answer can either be positive or negative. So the square root of x squared is x, and then the square root of 4 is plus or minus 2. Therefore, x is either positive 2 or x is negative 2. You substitute both numbers there, you realize that the answers will still be correct. And then let's go back to question 1 now. I decided to skip it and spare it for the end because it's a bit unique but easier when you come to think of it. So when you have a case like this, you can either bring the 25 here and use the difference of two squares to solve for t, but that will just make it hard. So what you do at this point, you can just introduce the square root on both sides since we have a square there. So the square and the square root will go, because the square root is like 1 over 2, then the square is like this. So when you multiply these two, you have a 1. So the square and the square root will go. So that means you remain with 1 minus 2t. Then the square root of 5, of course, this will be plus or minus. So this will be plus or minus 5. That means you have two equations to solve, in that 5 is either negative or positive. So you can say 1 minus 2t is either equal to 5 or 1 minus 2t is equal to negative 5. So now you can take either the 2t to the other side or the 1 to the other side. So I'll just take the 1 to the other side. I know we are trying to minimize the negative signs, but it's still okay either ways. So you take the 1 to the other side, you have a negative. Ensure to subtract the 1 from both sides. So you have 2t is equal to 5 minus 1, you have a 4. Then divide both sides by negative 2 to get rid of the coefficient of t so that you remain with t. So negative 2 into 4 is negative 2. So that means t is equal to negative 2. And then you can solve this one. You can say negative 2t, take the 1 to the other side. This will be negative 1. Then you have negative 2t is equal to negative 5 minus 1. This is negative 6. And then to solve for t, you can just divide both sides by 2. Negative 2, of course. So this and this will divide. It will give us a 1. So that you have a t. And then negative 2 into negative 6 is 3. So either x is equal to negative 2 or x is 3. You can even substitute them in there, and then you realize that in both cases you still get a 25. And then we can, okay, I'll skip this one because it's similar to this and that. And then question L, this is similar to the first one, but let's solve it anyway. This is our last question. So you have 2, and then x minus 2 to the power 2 is equal to 18. So to solve this, you have to get rid of these 2 first. So you can divide both sides by 2. So that 2 into 2 will go. Your aim here is to remain with this square number. You don't have to expand it, just leave it as it is, minus 2 squared, and you can't multiply this by any of these numbers inside because they have a square there, unless you want to put a square there and then you can do the multiplication. And then what is 2 into 18? This is 9. And then now, as you can see, this is similar to the one we are just solving, this one here, the part A. So all you have to do to get rid of this square is you introduce the square root on both sides. But remember, on your right hand side, always put plus or minus whatever the square root of 9 is. So the square and the square root will go, this side you just remain with this. In other words, these two are reciprocals of each other, so when you multiply them, you get 1 as a power. And then the square root of 9 is plus or minus 3. So you have two equations to solve now. You have x minus 2 is equal to 3, or x minus 2 is equal to negative 3. And then you can take the 2 to the other side so that you have x is equal to 3 plus 2. And then x will be 3 plus 2 is 5. And then this side you have x is equal to negative 3 plus 2. When the 2 goes to the other side, the negative 2 goes to the other side, you have a positive 2. In short, we are just adding a 2 to both sides. And then negative 3 plus 2 is negative 1. So that means either x is 5 or x is negative 1. You can even try to verify these answers and you will realize that they are both correct. So you have 5, I'm just substituting the 5 there, minus 2 squared. So this would be 2, 5 minus this is 3, then squared. Then 3 squared is 9, then 9 times 2 you have 18, which has satisfied the original equation. Then if you use negative 1, you still get the same correct answer. You put negative 1 there, minus 2, and then squared. Then this minus this will be negative 3 squared. Then negative 3 squared is just a 9, just like before. Then this times this is 18. And you're done.